So in this lesson, lesson number 2 on SLAAC or stateless address auto configuration, I aim to explain the operation of SLAAC. So at the end of the lesson, at least you are able to understand how SLAAC works and how we're able to manually assign IPv6 addresses to end devices. Okay, so we begin by looking at an overview of a SLAAC. Not every network has access to a DHCP server, but every device in an IPv6 network needs a GUA or global unicast addresses. As we go through this, I would like to remind you that there are at least 6 different types of IPv6 addresses. In IPv4, you learned about private and public addresses, and you learned about in private addresses the classful addressing. Remember, you have class A, class B, class C, etc. Class D, class E. Well, in IPv6, there are at least 6 different types of IPv6 addresses, and in this module we are looking at 2 of those addresses. In our first lesson we learned about global unicast addresses, that's 1, and we also learned about link local addresses, that's 2. So in this module we are looking at those 2 types of IPv6 addresses out of the 6 different types of IPv6 addresses. Okay, so here we're trying to look at or understand how we are able to manually configure IPv6 addresses to both routers as well as host devices. So again, you can see that not every network has access to a DHCP version 6 server, but every device in an IPv6 network needs a GUA. It needs a global unicast address. Now the SLAAC method enables hosts to create their own IPv6 unique global unicast addresses without the need for a DHCP version 6 server or without the services of a DHCP version 6 server. Now SLAAC is a stateless service. So what does it mean by a stateless service? It means there is no server that maintains network address information to know which IPv6 addresses are being used and which ones are available. Now there's a whole lot of IPv6 addresses available, but what's important in a network is for you to be able to manage the use of those resources, those IPv6 resources. So with SLAAC, the way the term used stateless is in the sense that there is no way in which you are able to manage and maintain the way PCs or host devices use address information and how they have been assigned. SLAAC uses ICMPv6 RS Messages to provide addressing and other config information that would normally be provided by a DHCP server. A host configures its IPv6 address based on the information that is sent in the array. Now we've done that, we've looked at that in lesson 1. Array messages are sent by the IPv6 or by an IPv6 router every 200 seconds. So the interval is 200 seconds. What type of messages, you ask? Remember those 3 types? Okay, the 3 flags. If you can recall those 3 flags, those are the messages. Now a host can also send, well, those are flags contained within the messages, if I can correct what I said earlier on. A host can also send a router solicitation. Okay, router solicitation. So now we are looking at another type of message now. It's not just array messages. Now we have RS messages, router solicitation. So a host can also send an RS message requesting that an IPv6 enabled router send the host an array message. Okay, so SLAAC can be deployed as SLAAC only or SLAAC with DHCP version 6. Okay, remember those 3 options: SLAAC, stateless DHCP version 6, which is really SLAAC with DHCP version 6. And then we have the third option, which is stateful DHCP. There's no SLAAC in there. Okay, so now we're going to look at how do we enable SLAAC. How do we enable SLAAC? Now, on your right, you can see an image that shows R1 with a global unicast address, the 2001. Anytime you see an IPv6 address that begins off with the 2001 and onwards, that's a global unicast address. And then link local addresses are the FE80. Okay, they begin off with FE80. Those are typically link local addresses. Okay, so in a minute I'll bring up packet tracer, and then as you are watching this video, you can pause and then create the packet tracer yourself, the file yourself, and then you follow through. It's a very simple network, just one router, one switch, and one PC in place. Okay, so in this diagram on the right hand side, you can see that there's a, let me just highlight that. You have a global unicast address and you have a link local address that's been assigned to an interface, manually assigned. That is SLAAC. Okay, that is SLAAC. We manually assign an IP address to end devices, host devices, or even intermediary devices such as routers and switches, if you're going to assign IP addresses to the interface. Okay, so you see here that R1, the interface G001, has been configured with the indicated IPv6 GUA and link local addresses. So in this case, R1 has these IPv6 addresses. Okay, it has 1, 2, it includes an IPv6 all nodes group address. Okay, all nodes group address. Now, all nodes group address, you remember the types of addresses. You have unicast, multicast, broadcast, that's IPv4. In IPv6, you have unicast, multicast, and anycast. Okay, anycast. This is what that anycast address is. That's the purpose of that address for anycast. All nodes, okay, all nodes group. So R1 here is configured to join the all IPv6 multicast group and start sending array messages. Okay, array messages to containing address config information to hosts using SLAAC. Okay, so let's begin this by creating a network, a simple packet tracer network with a router, a switch, and a PC. Okay, so you can pause this as you go through if you need to bring a packet tracer and do this. Okay, I've already added the 3 devices. So I have a router here. I decided to use the 4331 router, a 2960 switch. Okay, so you add the router, add the switch, add the PC. You can name them R1, S1, PC1, and make sure you join an Ethernet cable, straight through cable from port. It doesn't matter which port you use on the switch. I use port 24 to G001. Again, for demonstration purpose, to go in line with what we see on the what you see on the video, I decided to use the same port number, G001. Okay, so I'll click on that interface. Remember in lesson 1 that you can assign an IPv6 address through the method, through SLAAC method, to an interface using the SLAAC method by typing IPv6 address, and you type the address and the prefix. Okay, so we'll go ahead and do that. I'll go int G001 and I'll assign this address. Okay, so IPv6 address, and we assign the global unicast address. Okay, every IPv6 device requires, okay, every IPv6 device, enabled device, requires a GUA. A GUA purposely will be used. GUA is routable. Okay, a link local address is non-routable. It's like an IPv4 private address. Okay, so link local, oops, so I go IPv6, add FE80. So the first address we created, that's a global unicast address. This next one, I'll just put a question mark. That's how we create a link local. So you see, after FE80, one link local, that's it. Okay, so we've created 2 addresses. We've created the first one, it's a global unicast address. The second address is an IPv6 link local address. Okay, so although this can be automatically generated by the end device, we've decided to use SLAAC here to create this on our own, and instead of asking a DHCP version 6 server using SLAAC, we manually configured the global unicast address here by using this command, IPv6 address. Okay, so let's go no shut, and that should turn the interface on, and yep, that turns the interface on. Okay, and I'll just do an end here, copy run start, or you can do right to save that. Okay, close this. Okay, I'll just minimize that for the time being, but while you are doing that, keep this in mind. Remember that every IPv6 enabled router will start to send array messages periodically. Okay, it will start to send array messages. Now we've just learned now that in this first in the first slide, that in SLAAC, host devices can solicit. Okay, they can ask. That's what solicit means. They can ask. Okay, they can request an IPv6 enabled router for array messages. Okay, so that's where you have the array messages and RS messages. Router solicitation is when the host device is asking. Okay, router advertisement is when a router is advertising IPv6 information to hosts within that subnet where the router resides in. Okay, so we've done the first one. If you look down here, you can see we have IPv6 unicast routing. That keyword there is meant to enable IPv6 on a router. Okay, so let's not forget to let's do that. Let's just do that. IPv6 unicast. Hold on. Go back to conf t pv6. Okay, if I press the tab key, it completes that, and that's it. And save that. Okay, so I'll just minimize that for a while, and we'll go back to our video. Okay, so that's the first thing we've done. We've looked at how you are going to enable SLAAC. Okay, how you can enable SLAAC. Okay, so to create a global unicast address, IPv6 address, type in the global unicast address and enter. To create the link local address, instead of relying on the host device to automatically generate one for itself, you can type the link local address, end it with a link local keyword. Okay, so let's look at the next part. Okay, let's look at the next part. By the way, let's just go back to our packet tracer file, and if we can just let's see what options are available. Let's not stop there. IPv6 add, and I'll just leave a space. Let's go int g001 IPv6 add, leave a space, question mark. Okay, you see we use this IPv6 address. We typed in the address with the prefix. That was our global unicast address. We can enable DHCP by using this. So if I go IPv6 address DHCP, that means now I'm moving away from SLAAC. I'm going to stateful now. Okay. Obtain address using auto configuration. Remember the second option. Now we are going SLAAC. We are going SLAAC with DHCP version 6, which means that we can allow the device to automatically generate its own link local, but for the global unicast address, we are asking the DHCP version 6 server to provide that. Okay, that's where we go auto config. Okay, so these are some of the options. Okay, we've also used this to create the link local address. Okay, so that's just to make sure that you get this correctly. Okay, so that's on enabling SLAAC. Let's look at SLAAC only method. Okay, so we've done that. We've created the IPv6 global unicast address. We've created the IPv6 link local address. Now you're probably wondering, what about this third address? All nodes group. Did we create it? No, I did not create that address. Can you create it? Yes, you can create this address, and that's a challenge for you. You can create this address and follow through with sending a message, okay, sending to all IPv6 nodes on R1. Okay, so the show IPv6 interface command should indicate to us whether we've successfully created those addresses. So I'll go back to a packet tracer file, exit again. I don't want to use the do to bypass. Go show IPv6. What does it say? Show IPv6 interface. So go show IPv6 int, and it shows me a lot of details. So I go int. Let's try brief. Okay. So if you type brief, you can see that I've got these two interfaces configured. Now we are interested in so IPv6 int. We're interested in G001. So let's hit that, and you can see this now. Okay, so we've created our link local address. IPv6 is enabled. Link local address is there. We have a global unicast address. We've created that. Okay, that's our global unicast address. And notice the address array message will be sent every 200 seconds to the IPv6 all nodes multicast. Okay, all nodes multicast. Okay, FF02. That's this one here. See, all nodes multicast. Okay, so all nodes within that segment, the router will send. Okay, the router will send array messages to all the nodes within that particular segment. Okay, segment, when I say segment, I'm referring to the subnet. Okay, it will send array messages to all the subnets within this link here. Okay, within this network. Okay, so R1 will now begin to send array messages at an interval of 200 seconds. Okay, so we've enabled SLAAC. Let's have a look at the SLAAC only method. Okay, let's take a look at the SLAAC only method. So with the SLAAC only method, okay, what happens here? Now, with the SLAAC only method, I think by now we've seen so far that we can configure a router SLAAC only method by manually configuring a global unicast address and a link local address. Now the question now is in terms of, and we know that it will send every 200 seconds, it will send an array message to the FE02 FFE02 broadcast address, multicast address, every 200 seconds interval, array messages to all the hosts within that segment. The question now is, how does the PC pick up an address? Now, if you recall back, remember the three options? We have the flags. Okay, we have the flags, the three flags. If you can pause this video for a while and recall back to those three flags. What are those three flags? Okay, what's the purpose of each of those flags? Can you recall them? The three flags. Okay, the A flag, the O flag, the M flag. What's the A flag supposed to achieve? Okay, that's address configuration. A, address configuration, auto configuration, that is. O, other configuration. M, manage address configuration. So A is SLAAC only, remember. O is SLAAC with DHCP version 6, that's stateless. And then we have the M flag, which is stateful DHCP. Okay, so in this case, we are now trying to look at the A flag, okay, SLAAC only method, SLAAC only method. So with the SLAAC only method, it's enabled by default. Okay, remember that it's a default option when the IPv6 unicast routing command, which we did on our R1 router, as soon as we key that command in, it's enabled by default. So all enabled Ethernet interfaces with an IPv6 GUA or global unicast address configured will start sending array messages with the A flag set to 1 and the O and M flag set to 0 as shown here. So why is that so? It's self-explanatory. You can see A, meaning that it's SLAAC only now. Okay, so let's go to the router, our packet tracer file again. What this basically means here now is that we've enabled G001, okay, and it's supposed to send out array messages with the flag A value 1, okay, the others 0, O, 0, M, 0. So that indicates that the array messages that have been sent out from R1 to all the host devices within this segment or within this network are all SLAAC only flag messages, okay, array messages. Okay, so every 200 seconds. So let's go to PC1. Let's go to PC1, click on desktop, ipconfig, link local, okay, link local address. Notice for this host device, it automatically generated its own link local address, but it does not have an IPv6 address. Okay, if I click on auto config, okay, if I click on auto config, IPv6 auto config request successful. Do you notice what has happened here? IPv6 gateway FE80, where is this coming from? Okay, do you notice what's happening here? It has picked up an IP address, okay, because R1 is starting to send out router advertisements. When we set it to auto config here, okay, remember SLAAC stateless address auto configuration. Okay, so when we set it to auto config, the host device has automatically generated its own link local address. But for the global unicast address, what has happened? It has picked up one global unicast address from R1. Okay, can you see that? From R1. Now it also picked up something else. If I go back static, see, it does not have an IPv6 address. Auto config, it automatically picks up one, including the gateway information, IPv6 gateway. Now, did you notice something? The gateway information FE80 is the link local address of G001. Okay, so that's basically how a host device is able to pick up IPv6 addresses in a SLAAC only type of configuration. Okay, so the A flag suggests to the client that it creates its own IPv6 GUA. You've seen the prefix advertised in the array. Okay, so prefix is /64. The host generated its own global unicast, but it picked up the prefix from the array message. Okay, so the client can create its own interface ID using the extended unique identifier method or the EUI64, or have it randomly generated. The O flag, which is 0, and M flag 0, instructs the clients to use the information in the array message exclusively. So it does not have to be looking for an DHCP version 6 enabled router or server. Okay, so the array includes the prefix length, the DNS server, MTU, the default gateway information. So here we cannot see that. We can see the default gateway information being picked up. And there is no further information available from our DHCP version 6 server. Okay, so we don't have one yet in this network, but it has automatically picked up the default gateway from the array messages that have been periodically advertised or sent out by R1. Okay. So the next concept is ICMPv6 RS Messages, router solicitation messages. So we know now, by now we should know that router advertisements are sent every 200 seconds by an IPv6 enabled router to all the hosts that exist within the segment, okay, the subnet that it is connected to, through a multicast address of FF02, okay, FF022. The next concept we're looking at is router solicitation, and we also learned that host devices can query, ask, or solicit an IPv6 enabled router for array messages. Okay, so I think we've seen this happening already. we were able to see from our network, from our packet tracer network, the PC soliciting R1. Okay, we were not able to see this. It was happening in the background, soliciting R1 for array messages, and array messages were sent from R1 back, and then using that information provided within exclusively in the array message, PC1 was able to, when we selected an auto config using SLAAC only, it was able to automatically generate an IPv6 global unicast address on its own. Remember, it already created its own link local. It just needed a GUA using the prefix that was provided by the array, and it also picked up the IPv6 gateway information from the array as well. If there was no array configured, this would not have worked out well. Okay, so if we go back static and auto config, notice it says request successful. Okay, so request means it's soliciting. Okay, array messages, RS messages is being sent to R1. R1 responds with an array message with the information in the array message that will be used by PC1. So PC1 uses that information to create a unique IPv6 global unicast address. Okay, so the second last concept, host process, or the slide host process to generate interface ID, I think we've seen that. Okay, so it's all in the packet tracer file. Once you create a packet tracer file, you should be able to observe how this happens. So we can see that Windows, Linux, and Mac OS machines, the operating systems, they allow for the user to modify the generation of the interface ID. You remember the last value we covered in lesson 1? Okay, remember that? If we had not created our DHCP enabled interface, this end would have been a percentage symbol. Okay, percentage symbol. But here it has randomly generated. Okay, randomly generated an interface ID. Okay, so this is specific. Interface ID specific 8092 is specific to that device only. So every host device within that subnet will have a unique interface ID. Okay, so interface ID is the IP address of that host machine. Okay, and the rest shows. Okay, if I go back again, you see 2001 DB8 ACAD1. That's part of this network. Okay, remember we configured. Let me go back. Do show IP int brief G001. Hold on, what's wrong? Okay, exit. So IP IPv6, yes. Brief G001. Okay, so you can see here, that's the subnet. Okay, that's the subnet /64 2001 DB8 ACAD1. Okay, and colon. So the rest of the hex stats are all open. Okay, these are for the interface. Okay, that's the first 64 bits. The rest of the 64 bits is the user interface. Okay, EUI, extended EUI 64. That's what it means. The first 64 bits, as you can see here, the first 64 bits, that's the network. Okay, the rest is for the EUI. So the host itself, the operating system will randomly create that. Okay, randomly generate. It either randomly generate or use the EUI 64. So here we can see clearly in our network. Let me close this. See 2001 DB8 ACAD1. The rest of this 202 4AFF and onwards up until 8092, that's randomly generated by the OS. Okay, so it used the EUI 64. First part was the EUI subnet. The rest of it was for the host, and then you have the /64 and the default gateway provided or supplied by the DHCP enabled interface through the array messages. Okay, the last concept, duplicate address detection. Well, this question could have popped up in your mind. Is it possible that in this network, the possibility of what if I added another, okay, talking about that, let's add another device, PC2. Okay, edit to port 22. If I go to desktop, IP address configuration, let's go IPv6 static again. Notice link local automatically created, auto config. It's going to solicit now. It's requesting router solicitation. I'm getting tongue tied here. Anyway, it's asking the IPv6 enabled interface now. Okay, it's soliciting for an IPv6 address. It will take a while. So let me go back to static, auto configure again, request successful. And again, you can see that the first 64 bits is the subnet. It will be the same. The rest EUI randomly generated or using the EUI64. Okay, here you can see it uses the EUI64 because it goes /64. Okay, to generate its own IPv6 address. And again, we can see it picked up default gateway from this interface G001. So the question is, what if in the the process of requesting or soliciting for an address, we have a duplicate address, or we have the duplication of addresses? There is no guarantee that the address is unique on the network. Okay, that's the main thing. So this process we've seen so far enables the host to create an IPv6 address. However, there is no guarantee that the address is unique on the network. So this brings up this whole idea of duplicate address detection. Okay? Duplicate address detection, or DAD or DAD. So what's the purpose of the DAD? Well, it's self-explanatory again, to detect whenever there is a duplication of address in this whole process of router advertisements and router solicitation. So far we've learned that SLAAC is a stateless process. Therefore, a host has the option to verify that a newly created IPv6 address is unique before it can be used. So you see, in this way, the duplicate address detection process is now used by a host to ensure that the IPv6 GUA it has created or randomly generated is unique to itself, to ensure that there is no duplicate of addresses in the network. You saw that in operation here. When I added PC2, I went to ipconfig, auto-config. It took a while. See, it took a while. That router solicitation has to happen fast. It has to pick up that router advertisement, generate its own IPv6 address, and then use the ICMPv6 neighbor solicitation, NS, okay, neighbor solicitation, to ensure that its address that it generated is specific to its own or unique to itself, and that address was not generated by other devices as well. Okay, so this was basically to do with the last 24 bits of the IPv6 address of the host that was created. So if no other devices respond with a neighbor advertisement message, then the address is virtually guaranteed to be unique and can be used by the host. Okay, so you see here, we've just come up with another two terms again: router advertisement, router solicitation, neighbor solicitation, neighbor advertisement. Now I put them, I call those terms in order of their importance in the whole process we've seen so far from lesson 1. You see, we talked about router advertisements. Okay, routers advertise every 200 seconds. Okay, they advertise, and array messages in IPv6 info. So array messages are used by host devices to generate their own global unicast addresses. And in the event that you connect a host device to a network and it does not receive an array, it will send out router solicitation. Even another router on the network, it will send out a router solicitation to ask for array messages. once it receives an array message, it generates its own IP address. It then sends a neighbor solicitation, NS message, to ensure that NS is used in the duplicate address detection process, to ensure that its address, the last 24 bits of its IPv6 address, is unique. Once it receives a neighbor advertisement, that confirms that, okay, go ahead, you can use that address. So if the NA is received by the host, then the address is not unique, okay, and the host must generate a new interface ID to use. If it does not receive a neighbor advertisement, that means that the address is unique, so it can go ahead and use it. Okay, so very important concept here, but just note, just take a note here that that is not really required, okay, because the 64-bit interface ID provides 18 quintillion possibilities. Now this comes from the fact that IPv6, there's about 4.6, about 6 undecillion addresses. You see, that's another word coming out of the quintillion. There's just a whole array of addresses, possible addresses that can be used. So it's very unlikely that duplicates will be detected in any case in a network, okay, because the 64-bit interface, again, notice here that it provides a whole lot of possibilities that can be used, and you don't have that number of devices in a network. It's just not possible at all. So the chance of a duplicate address is very remote. However, IETF recommends that DAD be used. Okay, so most operating systems perform DAD on all IPv6 unicast addresses, regardless of how the address is configured. Okay, so let me bring those concepts again into context. We begin our discussions by having a look at SLAAC. SLAAC only, remember, every IPv6, every host device, if it's IPv6 enabled, requires a global unicast address. It already has a link local address randomly generated by itself, but it needs a GUA. And if you're going for SLAAC only for a router, you can configure it. Okay, you can configure it using the IPv6 address on the router, on the interface itself. You can even configure a link local for the interface, okay, by typing in the address FE80 and link local at the end. For a host device relies on the array messages. So it will be expecting the array message. It will randomly generate its own link local, but it will be relying on the array messages for it to generate its own global unicast address. And then we also learned that apart from the array messages, RS can be also used. Okay, it can do a router solicitation to request for array messages. And in the event that once it generates its IPv6 global unicast address, chances are it could be duplicated, but we've learned that those chances are very rare given the wide possibility of addresses that are available. However, IETF recommends that still be used. So in that process, we learned about two more messages. That's the neighbor solicitation, where the IPv6 enabled host device has to ask other devices whether the address it has generated is unique. If it does receive a neighbor advertisement, that means the address is not unique. So it must generate a new interface ID. But in the event that it does not receive a neighbor advertisement, okay, that confirms that the address is unique. Okay, so that's lesson number 2 on SLAAC. Lesson number 3 will cover DHCP version 6, and that should bring us to the end of module 8.